Hi everyone, welcome back to our channel, Becoming a ROS developer here at YouTube. My name is Rodrigo here at the Construct, and today we have one of our students, Natalia, who has completed one of our courses. This is ROS Basics in 5 days for Python. And at the end of this course, you can present a project on a real robot to get a certificate. And that's what we're going to see today. Natalia do is show us her project for this, her final project on a real robot for this course. So we're going to be watching that today. Hi, Natalia, how are you?
Hi, fine, thank you. And you?
I'm very well, thank you. Very excited to see what you've done with your project. So whenever you want, you can start sharing your screen and
Okay,
showing us what you've done.
okay, perfect. So let me share my screen then. Um, okay,
All right, I can see your screen.
perfect. So the first thing that I'm going to do is just, yeah, launch this main launch script
Mm-hmm.
to see how the robot performs. So the idea here is that the first thing is, yeah, that the robot will start looking for the closest wall. So it's turning to find this position that it will be the yeah the like it's measuring the distance like the laser that the point that is in front of it, just in the middle.
Okay, so it's going to look for that wall on its left,
Yeah.
right?
Yes.
It seems like it has found it, maybe.
uh, I don't think it has found it.
Okay.
Actually, yeah, sometimes, but because I have a range
Ah, I
exactly
see.
in the bins, and it could happen that it doesn't find, so it continues doing it, or it may happen that it's also confused by the obstacles.
Oh, I
But I don't
see.
think this is why I try to put it like a bit closer to the wall of the left,
I
so
see.
it doesn't continue the loop. But
And what is
hopefully,
the range you're looking for?
I have like three pins in the laser, so it's
Okay, I see.
like 359 and 361, if I am correct.
Uh-huh. So maybe you didn't find it because the range
Yeah,
is.
it happened because sometimes when I was like doing like the like increasing this range, so it could happen that the robot actually was like not facing like the wall.
Ah, I see.
It's a bit weird. It's not working.
Oh,
Can
why don't you try, yeah, closing it and launching it
yes.
again? But rotate it so it will find it. We don't have to wait for a whole rotation.
Um, yeah, I just tested like it worked. Mm,
So this is then the service server part. All
yes.
right.
So what I'm doing here is that now I launched like the kind of main script that is following the wall, and it calls for the service server. That is the server that actually rotates to find the wall and approach the wall, and then place the robot in the right location to start following the wall. And this is actually what we are doing here. So we can see that it says that the service move nearest wall has been called.
Uh huh.
Uh, and it's not working. And I don't know why.
It seems like it's not finding it, huh? What
Yes,
if you move it to
I will do
another
that. Yeah.
location?
Yes. So I will try to rotate it a bit. So it's, I wouldn't say that the problem is because,
So maybe we can actually try and increase that range or something in order to force the completion of the service,
Yes.
no?
Yeah, I can quickly show you
Yeah, yeah, that's good.
here. This is actually this is the range that I have. So what I think that I do is like find the index of the minimum value, the minimum distance that the robot has at that moment, and I sent like the index would be like this laser beam,
Right.
uh, and like depending of this yeah, like the value. So what I did was, okay, if like the minimum value is within this uh, range, so it means that the robot is in this case facing the wall.
Hmm.
But it's a bit weird. That is, oh, it's moving.
Oh, I found it. Nice. I think it's because you only have four or five beams. So
Okay.
some maybe the operation is not done uh, quickly enough while it's rotating, and
Okay,
while
could
it's
be.
done. So if you would put like I don't know 20, I mean whatever 100 beams, it would
Yeah.
always find it. But
Okay,
there's a
that could
balance
be.
there.
That could be. So yeah, that I what it did was actually, yeah, like maybe we have some messages here that was like turning to start following the wall, and then like started to follow the wall, and here yeah, is moving like along the wall, and also the action has been called, and
Yeah,
the
I can see.
feedback is the distance that the robot has traveled so far. Yeah, so
So once it's completed the lab, is it going to stop?
yes. So what we like I read from some forums, the construct is that the 6 meters is more or less the
Uh huh.
distance that the robot travels until like completing one lap. And this is what we expected here, that when it's like has traveled more or less 6 meters, so the robot stops and prints the odometries. That will be, yeah, here.
Oh,
So the
awesome.
robot here stop, and we can see from here that yeah, one lap is complete. Then like the process of the call like has, or in this case, it has like the robot stops, so the process is finished, and then we print the odometries. That is the list, or yeah,
So that
the
is the list of
positions
all the
and
prints.
theta.
Okay.
Yes, and that is more or less like the trajectory of the robot, right? I would say.
Mm-hmm. Mm-hmm.
Yep.
Awesome.
So this is with some uh, like problems at the beginning, but this is more or less what I did, so I can explain the code quickly.
Yes.
So the first thing that we have here, I would call this, that was like my main script, that is this following the wall action client class. And what I did here was designing this following the wall class with some kind of initial values that was when the wall was found to kind of sort the result that is coming from the service
Yeah.
as the service server. Yes, we have some current distance, and we have also the regions that we have right, front, and left. That is to sort information of like to follow the wall.
Mm-hmm.
We have also the subscriber and publisher. So the subscriber like reads the information from the laser that is in the topic scan, and then we have also the publisher to try to what we do is, yeah, kind of write the velocities in this topic. And we have this variable bar that is just from the twist package here.
Mm-hmm.
That is like the geometry, so the velocities and the linear angular velocity. The second part is calling the service. So this is the service that the which that I use to start moving the robot, and is looking for the closest or nearest wall. And yeah, I just like here, we just kind of call the service, and just wait for the service to execute its task. And this is the service that
Mm.
the thing that I did was just the service that we designed the second part kind of like work perfectly. So I didn't need to modify it. So as I was mentioning before, the thing that I do here is okay, of course, design the or write the subscriber and create the service and kind of have this call that is a
Mm-hmm.
service callback. So what I did here was kind of looking for the value in the laser that has the minimum distance. And it means that, okay, this minimum distance will indicate that is at in this case will be a wall or could be also the obstacle as
Uh-huh.
maybe we found in the example. But the idea is that I use this information to uh, tell the robot, okay, like here we can have like a wall and you need to approach that. So yeah, the first thing that I do is using this values to first like looking for the distance, the minimum the minimum distance in in front of the robot, and then like trying to turn the approach the robot to the wall, and then turn the robot so the right part of the robot
Mm-hmm.
is facing the wall, and then we can just have the robot to in the position to move. So this is what the service do.
All right.
That's and then what once the service has finished, like we send this result here that the wall was found and it's true. So so when we kind of recall or this result here, and when we said that the yeah that actually the service has finished its task. So what we set is this variable that we have at the beginning as true. And then in here in this part, we call the action, and the action is designed to record the odometries of
Uh-huh.
the robot. Um, so here, this is like just calling the action, and the action server is here. So this is again like how we initialize or I initialize the action
Yeah.
server. And what I do here, yeah, is calling this, yeah, this server action server and just like setting some variables to start to um, compute or calculate this distance that is going to send, that distance that has been traveled too far to send to them as a feedback. And also, of course, I will start like subscribing and reading some information of the position of the robot because that
Uh-huh.
information is information that I'm going to save as a result or and as the geometries of the robot. So this is just we said like we need like the position x and y and also the orientation that was theta, and this is saved here in this odometry data that has uh, is the type point. I know that in the requirements was 0.32, but for whatever reason it didn't work in my case.
Oh yeah, it doesn't
So
matter. It's just
okay, yeah. So
just
I checked that the difference is one is float 32 and the other is float 64. So
yes, yes.
yeah, this is why I use this. Maybe something that you've mentioned is that for this action I use this message that is the will be the result that is the list of odometries and the feedback that is the
Which is what we were seeing in the terminal,
yes,
right? Okay.
exactly, yes, that will be this is the result and all of this is the feedback.
Mm-hmm.
So yeah, if we come back here, I just have like a very simple uh, function to compute the Euclidean distance here, and this is just the callback for this action server. And what I do is to compute this distance. So I initialize this kind of x1 and y1 with the initial values of the geometry data. and then I just like enter into this loop until this total distance that I have has the distance of one lap, that is 6 meters. And yeah, I con I cal I compute the distance, I publish the feedback, and then what I do here is I start to append the odometries in this list trajectory, and then this list trajectory is what, when I have finished, when it's complete, I will store this as the in the result of the action message, and then I print the odometries.
All right.
And yep, so this is like what it does. And we have here some in this main script, like the feedback also. We have this feedback that kind of prints
Mm-hmm.
the feedback that we are receiving from the
From the action.
action server. And we also have this callback that is for the subscriber. That is actually the callback that kind of follows the wall. So what it does here is I initialize these regions with the the positions of the laser that I should consider when following the wall,
Mm-hmm.
and I just like kind of tweak here to follow the wall
Yes.
according to the instructions. Yep, and then I publish. And finally, what I do is okay. Once current distance that I have at the beginning, that I am yeah, I am here kind of
Checking.
updating with the
Mm-hmm.
feedback that I receive from the action is higher than 6 meters. So it's an indication that one lap is complete. And then I stop the robot and stop. Yeah, and then the robot stops. And that's what.
All right. That's awesome. And that's the whole behavior that we saw in the robot.
Yes, yes.
All right. Very, very clear. Congratulations, Natalia.
Thank you.
Do you mind stopping sharing your screen so we can take? There
Yeah,
you go. Nice. All right. So, congratulations, Natalia. Very clear,
thank you.
very well explained, and very simple through the steps that you had to achieve. Uh, that's I really liked how clear it was, and I also really liked that last part. You actually used the action feedback to control the main program, the main node to make it stop. I think that's very clever, and that takes advantage of the uh, sort of advantages of an action that you can, you know, do other things while the action is still happening, as opposed to, say, a service
Yep.
server. So again, congratulations. Just a couple of questions, actually, just one question for the sort of little overspin we had at the beginning where it couldn't find the wall. So, based on how you saw it behave, what would you do to ensure that the robot finds the wall right away? Like, what would be like the solution for that you would try to force it happening?
Yes, like solution, maybe the first thing that comes to my mind is that you said maybe like have this range a bit bigger,
Yeah.
because if it's a small obstacle, so I would say that maybe some part could be like some part of the range is not actually measuring that distance, because the obstacle won't cover that range. But another thing that I have here that is coming from the first example is that at some point when the robot like gets lost, so I am following the wall, and just imagine that is an obstacle. So after like walking at some point, like this value is going to be infinite.
Right.
So
Oh,
in that
yes.
case, what the robot does is start looking for the wall again. So start rotating in one direction to find the wall.
Uh huh.
So that could be one option to like to avoid this to happen. And also I apply something like to for the using the left, that this is not rotating but using the left measure when there is an obstacle, so that I keep away of like I move away from the obstacle, so I
I
don't
see.
use the obstacle as a reference point
All
to
right.
follow the
Yeah,
wall.
yeah. Those are good
This is
ideas.
like this is one thing that I did, and I didn't have the. I mean, none of my examples, like the robot was actually crashing the obstacle or moving too far to the
Hmm.
too close to the obstacle. But yeah, it's implemented here. So, but I would say that the first thing that the robot does is when it sees that the right um, beam is not within the like the range distance, so it starts looking for the wall again.
Okay. Yeah, yeah. That's a good idea. And now that you mentioned that infinite sort of issue, that sometimes in the real robot you get some infinite values based on, I don't know, the reading not coming back quick enough, or maybe being too close. And that's an interesting thing that you said, because maybe that's actually the issue. And just to mention, there's a way to get rid of the infinite values, but of course, if all in the beams that you're looking, if they're all infinite, you're gonna have problems there. But that's a really good point. Um, I think that that would really work. And I mean, other than that, Natalia, I don't have any other questions because it was very clear. So I just want to congratulate you again, and yeah,
Thank you.
very, very
Thank you.
nice work. And to everyone else that is watching, you can do what Natalia did here to obtain a certificate for our courses. You can prove your learnings in this format and get a certificate from the construct. So I invite everyone to do the same as Natalia. Um, thank you very much, everyone, for watching, and we'll see you next time. Bye bye.
Bye.
Ok, muy bien.